So I'm going to go through some different situations that limiting reactant and stoichiometry problems can give you and different things that they can ask you. And I'm going to help uh, guide you through them in terms of like a conceptual plan on how to solve these. So I'm not going to go through a specific problem and tell you how to solve it, but I'm going to give you an example using just very general terms. So here we have a very general reaction. A plus B gives us C. And let's say a problem is asking how many grams of C will form when, whatever amount of grams of A reacts with excess B. So on this problem, we don't have to figure out the limiting reactant. And we know that because it's saying B is in excess. So we don't need to sit there and calculate any limiting reactant. We know that A is a limiting reactant, and that's why they gave us the amount of A. So how do we go about getting to grams of C? We have the grams of A, right? So we need to go from A to C. We're going to use the mole map to do that. So in this case, we're going to consider our A to be actually A, so it does match up A. And this will be C, C, everywhere you see it. Just replace it if that'll help you. So we're starting off with mass of A. That's our first known, right? That they actually gave you that number. We're starting off right here. We need to get to mass of C. So we need to get there. That's our starting. This is our unknown. This is our known. So our starting place. We are going to follow the mole map until we get to our unknown. So that means we're going to use the molar mass to get 2 moles of A. From here, we will use the stoichiometric factor to get to moles of C. From here, we will use the molar mass of C to get to mass of C. And I'm just going to provide a general dimensional analysis setup so you can see that. And again, I'm going to be using very general terms. So I'm just going to use the pound sign for numbers, but pretend it's an actual number obviously when you actually solve something, like for example, problem 7. So let's set up our known. You're going to start off with whatever grams you have of A. Oh, and your first step is to balance your reaction. We are going to pretend, okay, I already balanced it. So my ratio is 1 to 1. Okay, but for you, always check if the reaction is balanced first. From there, you do your prep work where you find the molar masses that you need. So for the molar mass of A, you would find it and whatever it is, because you know you're going to need it at some point. And then you are also going to need your molar mass of C. So you find all the molar masses that you need, and I'm just going to make something up, 10 grams per mole. And this is 20 grams per mole, all right? Finally, you also need your stoichiometric factor. Our stoichiometric factor in this case is that 1 mole of A reacts to form 1 mole of C, okay? So I'm keeping it simple. But your stoichiometric factor, all it does is it comes from those coefficients. So, okay, now we are ready to set all of this up. So we have our mass of A. We are going to convert it to moles of A by setting up the molar mass. So 10 grams of A, 1 mole of A. Now we are at moles of A. We need to use the stoichiometric factor to get to moles of C. And let's make sure everything cancels out. Grams, yes, moles of A. So now we are at moles of C right here, which is good. We're one step closer. And then finally, we just set up our molar mass of C, which is 1 mole C, 20 grams C. This cancels out. You end up getting grams C as your answer. And that's the process. So first balance. Get your prep work done, make sure you know where you're going on the mole map, and that'll guide you and it'll take you from whatever you're starting with to your unknown. Next, we have another two situations. So again, we have the same little mock reaction, and we're starting off with mass of A, mass of B are reacted. How much of C will form? How much excess product will be left over? So our first problem is asking for the limiting reactant. Anytime you are given two masses and then the question asks how much of the product is formed, that means you need to do the limiting reactant test. And then from there, you can calculate a bunch of other things. But first, our first step is to find the limiting reactant. So you're going to go through the same process. So we need to take each of these, A to amount of C, B to amount of C. Whichever one of these, either the A or the B test, gives us the lesser amount of our product, C, that is your limiting reactant. So let's say we're going to set this up. How do we do this? Regardless of whether it's A or B, we're going to start here. And let's say, so this is our reactant. I'm just going to make this general. Moles of reactant, just so it applies to both A and B. And then this is C, your product. You are going to start off with your mass of your reactant. You go to the moles of the reactant. You use the stoichiometric factor to get to moles of your product, C. And then finally, molar mass of C to get to your mass of C. Or actually, yeah. So let's say it was asking how much of C will form in grams, okay? This is very specific, just so that we know we're going all the way here. And that would be your process. So let's set one of them up. So let's say we are, and actually I'm just going to make this general. So I'm just going to make this mass of your reactant. You're going to set it up. Whatever the molar mass of either A or B is, you're going to set it up right here. So grams reactant, mole reactant. This is the molar mass. Okay, so now you got from mass of your reactant to moles of the reactant. From there, you are going to set up your stoichiometric factor from whichever reactant you're starting with to the product. And this is mole. Now, how do you get the stoichiometric factor? So just to remind you, this, let's say it's already balanced, right? Everything's 1-to-1 somehow. This would mean that your stoichiometric factors are 1 mole of A reacts to form 1 mole of C, 1 mole of B reacts to form 1 mole of C. What if you had an equation that was like this? 2A plus 3B equals 2C. Then here, your stoichiometric factor would be 2 mole of A form 2 mole of C, 3 mole of B form 2 mole C. So you got to balance it, make sure you have all your coefficients right, and then you can find out your stoichiometric factor. In our case, right here, because I'm keeping it simple, everything is 1-to-1, okay? So you use that stoichiometric factor. And then over here, this was our molar mass of whichever reactant you're working with. And then from we're at here, now we can finally go to mass. So you just take the molar mass of your product, C. Oops, I set this up wrong. So your mole would go at the bottom. 1 mole C, and then whatever grams C, whatever the molar mass is. So this will be the molar mass of C. Okay, so right here I'm just being general, writing reactant. You would do this twice, basically. You would do this starting with A right here, going all the way to C. And then you would do it with B, going all the way to C. Both of them. Whichever one of these two gives you the least amount of C, that is going to, so let's say this one gave me less, right? A gave me less. That means A is your limiting reactant. So that's why I call it a little test. You test how much each of these give you, like for product, and then you see how much you get. Whichever one gives you less, that's your limiting reactant. Now, that is your first problem. Your second problem is how much excess product will be left over. To do this, you, again, because your limiting reactant is limiting the amount of product you make, it's also actually limiting the amount of excess that is used up, right? Because your limiting reactant is the one that's going to run out first. So I would go ahead and take my information from A. So I would just start again with A, mass of A this time. So let me erase this. Again, always use the mole map. It really helps a lot. Okay, so let's say A was our limiting reactant, right? I would start with mass of A, go to moles of A, use the stoichiometric factor between A and B to get to moles of B and then mass of B. That will tell you how much B you used up, and then however much B you used up, you can subtract that from your original starting amount of B. That will give you leftover B. So it's a very similar setup to the one we have here. From here, right here, we were going from reactant to product. Now we are going from A to B. So your stoichiometric factor is what decides how you set this up. Like it's going to be what's different, and obviously the molar mass because corresponding to B. What about whenever a problem asks you to find the percent yield? So here we have when this amount of A reacts with excess B, right? So this time we don't have to find the limiting reactant. It's telling us that B is in excess, so you just leave that alone. We have a certain amount of A reacting to form this amount of product, right? What it's telling you here is that this is your actual amount that you formed. Like, again, think of you being in the lab. This is how much you formed. So that's your actual yield that is given. What you need to do is take this mass of A and you are going, now this time, again, the mole map is your best friend. This time you are starting off with A and you need to get to your theoretical yield of C. So you need to start off with mass of A, go to moles of A, use your stoichiometric factor between A and C to get to moles of C, and then mass of C. That will give you your theoretical yield. So let's go ahead and set this up. We will take our mass of A, whatever the molar mass of A, from there you would set up your stoichiometric factor. So let's say again, in this case, everything's 1 to 1. So 1 mole of A reacts with 1 mole of C. From here, so now we use that to get to moles of C, and then you just use your molar mass of C. We get grams of C. So this right here is your stoichiometric factor. This right here is your molar mass of A. This right here is your molar mass of C. From here, you will get mass of C, your theoretical yield. So we're not done because the problem is asking for percent yield. How do we do that? You are going to take your actual yield that is given in the problem. It has to be given in order for you to calculate this. In grams, you're going to divide this by your theoretical in grams, times it by 100, and that gives you a percentage. So always use the mole map. It definitely helps. Make sure everything is balanced before you even start anything. Make sure you have your molar masses ready to go in order to set up your dimensional analysis. For these problems, always set up dimensional analysis. You can do it in chunks if you need to, like you can just do this part first and then continue on with the number that you get from there and do this part. It's up to you. I set everything up at once. It's just easier for me to see and for me to realize what I'm doing. You can label everything the way that I am just so that you know where each of these numbers is coming from, and that'll definitely help you.